Module 1, Lesson 15, a synthesis of representations of equivalent ratio collections. So a synthesis is where we take all of these different things that we've been doing and we kind of put them together. So we're going to look at all the different things we have done with equivalent ratios, and we're going to do that all in one lesson. So we are definitely writing ratios. We are definitely reasoning about equivalent ratios, and that fixed relationship, that constant, is of course part of what we're looking at. All right, so I can associate each ratio with the ordered pair. So building off of the last lesson, we've got a ratio that can be turned into an ordered pair. We can then put the ordered pair on the coordinate plane, use a given ratio table to create ordered pairs and plot them in the coordinate plane, observe the ordered pairs lie on a line through the origin. So this is looking at, it starts at 0, 0, and the line goes from there, and explain that the coordinates in the line satisfy y equals kx. K is the value of the ratio, so our constant. And of course, mixed in here, we have to be able to find equivalent ratios, we have to be able to work with ratio tables, we have to be able to do all of these other things that we have been working on. All right, so this is an exploratory challenge. So in class, this would be I kind of turn you loose, but here I'm going to just walk through the lesson. So at the end of this morning's news segment, the local television station highlighted area pets that need to be adopted. The station posted a specific website on the screen for viewers to find more information on the pets shown and the adoption process. The station producer checked the website 2 hours after the end of the broadcast and saw that the website had 24 views. 1 hour after that, the website had 36 views. So what we've got here is a real-life situation. We've got some information, and now we are going to work through this information with a variety of tasks. All right, so our first task is to create a table to determine how many views the website probably had 1 hour after the end of the broadcast based on how many views it had 2 and 3 hours after the end of the broadcast. And using this relationship, predict how many views the website will have 4, 5, and 6 hours after the end of the broadcast. So hidden in here, it is implied, and we are supposed to infer, that it's going to have about the same number of views every single hour. And we need to create then a table of equivalent ratios. So I'm going to create my table here, and I'm going to have the number of hours, and I'm going to have the number of views, and I'm supposed to make a prediction for 1 hour. I am given information for 2 hours and 3 hours, and then I need to make predictions for 4, 5, and 6. So after 2 hours, there were 24 views, and after 3 hours, there were 36 views. 1 hour after that, after what? After 2 hours, so 2 hours, add one more, 36 views. And now I need to complete the table of equivalent ratios, make some predictions here. Well, I notice that I am multiplying times 12. I'm taking the number of hours and multiplying by 12. So I've got 12 views after 1 hour, 48 views, 60 views, and 72 views. So here we are working with a table of equivalent ratios. All right, so looking at the next question here. Come back here. Oh, let's come back. A little jumpy this morning. All right. Got my table. All right, so let's take a look here at the next set of questions. The first question is, what is the constant number that makes these ratios equivalent? Well, that's 12. We are taking the number of hours and we're multiplying it by 12 to get the number of views. So my constant is C. And now we're supposed to write the equation for this. Well, we've worked on this multiple lessons. So my ratio of hours to views is 1 to 12. So it has a value of 1/12. So the number of hours is 1/12 the number of views. And if I do views to hours, I have 12 to 1, which is a value of 12, and the number of views is 12 times the number of hours. And if we look at the instructions here, I've used V to represent the number of views. I've used H to represent the number of hours, and I have a constant of 12. And they wanted to represent the relationship between the number of views and the number of hours. So that would be this one right here. The relationship, the ratio of the views to the hours. So the views are equal to 12H. All right. Let's take a look at the next one here. So now we're going to use our table from exercise 1, and we're going to create ordered pairs that could be graphed. So I could take my table here and I could actually add another column here, and I could have it, I'll call it P for ordered pairs, and I've got 1, 12, 2, 24, 3, 36, 4, 48, 5, 60, 6, 72. And of course these are ordered pairs, so they all need to have the parentheses around them. There we go. So I've got some ordered pairs. Now, you can probably make a guess what we're going to do next. Now that we have the ordered pairs, it's time to create a graph. And as we reviewed in the last lesson, it's important to make sure my intervals, how far my numbers are spread out on the x and y, is consistent. Doesn't mean the x and y have to have the same interval, but it just means that the interval has to be consistent. So whatever I do on the x, if I'm going to count by 2's, I have to count by 2's and spread them out the same. Well, let's see. I've got 1, 2, 3. I'm going to go every other line on these, I think, just because I have a lot of room. So here's 1 hour, and here's 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7, 8, 9, and 10. So I can run that up to 10 hours there. So each of these little lines in between is a half an hour. If I ever wanted to do anything with half hours, I could. All right, now it would make the most sense if I were to count by 12s going up here, because I have multiples of 12. And I'm going to do the same thing. I'm going to go every 2 lines. So 12, 24, 36, 48, 60, 72, 84, 96, 108, and 120. Which means that every one of these little guys here is 6 hours. Sorry, 6 views. Hours is on, oh, I should label this. So this is views. And this down here is hours. There we go. And I'm supposed to put my ordered pairs on here. So 1, 12, and 2, 24, and 3, 36. And at this point, I notice I've got a pattern of going up 2, over 2, up 2, over 2, up 2, over 2, up 2, over 2. And I can double check as I go. 5 lines up with the 60, over 2, oh, so up 2, over 2, and the 6 lines up with 72, and I can connect all of my points together to make a line. And the origin is down here, 0, 0. So in the ICANN statements here, taking a look, I'm going through the origin and I have a line. All right, so taking a look at the next question. How many views will the website have after 12 hours? And it says I need to use at least 2 different representations to justify my answer. Well, I certainly have my table that I did earlier, but I'm going to look at a tape diagram here. So I know that I have a ratio of 1 hour and 12 views. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Great. And I know that my constant is 12. So I know that this, so I take my 1 and I multiply it by 12, and that's where I get my second tape from. If I have 1 hour, I have 12 views. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so there I've got a ratio of 1 to 12, but they want me to say, what if it was 12 hours? So I'm going to put a 12 in my box, in my units, 12. And now I've got 12 boxes of 12, so after 12 hours, there would be 144 views after 12 hours. And I've just proven that with a tape diagram. If I wanted to use a double number line, and this isn't a great question for double number line, but not a bad one to do double number lines with. One hour, 12 views. 2 hours, 24. 3, 36. 4, 48. 5, 60. 6, 72. I could always count by multiples of 2 instead of ones. So I'm going to start this again because I could just keep counting that up to 12, but I could do something like this. 2 is 24, 4 is 48, 6 is 72, 8 is 84, 10 is 96, and 12 is 120. Although I'm pretty sure I did something wrong there. After 12 hours, 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, 12 hours. I multiplied by 10, not by 12. 10 times 12 is 120, and 12 times 12 would be 144. So I'm not counting by the right numbers here. Right about here I went sideways. It's a good thing I went back and double checked my work. There we go. Now we're multiplying by 12, so that looks a whole lot better. So I've got my number of hours, and I've got my number of views. All right, taking a look at exercise 6. So also on the news broadcast, a chef from a local Italian restaurant demonstrated how he makes fresh pasta daily for his restaurant. The recipe for his pasta is below. He takes 3 eggs, beats them, takes a teaspoon of salt, 2 cups of all-purpose flour, 2 teaspoons of water, and 2 tablespoons of water and 2 tablespoons of vegetable oil. And I am supposed to find the ratio of the number of tablespoons of water to the number of eggs. Tablespoons of water is 2, and the number of eggs is 3. So I have a ratio of 2 to 3. And then I need to come up with some ordered pairs, and so use the ratio, make some ordered pairs. So it's 2 to 3, and this would be 6, and this would be 9, and this would be 12, and this would be 30, and this would be 30. Boy, where did I get 30 from? That's crazy stuff. How about 15? And then 18. There we go. All right, and now I need to make some ordered pairs, and this is 2, 3, and this is 4, 6, 6, 9, 8, 12, 10, 15, and 12, 18. And they would like me to now put this on my graph. All right, so let's see here. Well, I could do 2, 4, 6, 8, 10, 12. And this is, of course, the water in tablespoons. And this is the eggs. And I think for the eggs, what shall I count by? Yeah, I think I'm just going to do 3, 6, 9, 12, 15. Yeah, that'll be okay. I can do it a lot of different ways. All right, and now I need to plot the points. And I've got 2, and 4 goes with 6, and 6 goes with 9, and I notice I'm once again going up 2 and over 2. Oh, except I didn't go up 2 on that one. It's a good thing I double checked, huh? About got my graph put together wrong. There we go. Up 2, over 2, up 2, over 2. And I can connect these together. Now I know on the graphs that I've done in this lesson that it's up 2, over 2. That has to do with the intervals that I'm picking. I could certainly change the intervals on the x or the y axis, and then it wouldn't be up 2, over 2. I could make it so it was up 3 and over 2. I could make it so it was over 3 and up 2. There's a lot of different ways. It just happens to be on these graphs that I'm ending up with up 2, over 2. All right, so let's take a look here. And it says I'm supposed to use my graph to figure out how many would be needed for 16 tablespoons. And you can see that my graph is shifted just a little bit when I came on to this slide. So I'm going to back up one so that my graph is working consistently. And so down here on the bottom, I'm at 12, 14, and 16. And if I track this 16 up, that's where it crosses my line. And so if I track back over here, and I know that I'm counting by 2s, I've got 20 and 22. So I would find out if I have 16 tablespoons of water that I would need 22 eggs. All right, and then determine how many tablespoons of water will be needed if the chef is making a large batch of pasta and the recipe increases to 36 eggs. And it says support your reasoning with at least one diagram you find applies best to the situation and explain why that tool is the best to use. So we have, of course, tape diagrams, double number lines, tables, equations. We've got graphs. So we have a lot of options here. Of course, it does say diagram. I don't think equation counts as a diagram. So I need to go up to 36 eggs. Now, I've got my graph going here, and I could continue to extend that, but I'm not going to use the graph on this one. I'm going to go back to the good old standby of the tape diagrams, remembering that the ratio of the water to the eggs is 2 to 3. And the eggs need to be equal to 36. And I can see that the 36 is split into 3 parts, so that each unit will be equal to 12. And because I have a ratio, these units would be also 12, which would tell me that the water needed for 36 eggs is 24 tablespoons. So if I've got 36 eggs, I need 24 tablespoons of water. And I'd used a tape diagram for that. I could also use a double number line. And I've got 2 to 3. And I could certainly, and this is an awful lot just like tables of equivalent ratios, I can do some multiplication here. I can say, hey, I'm going to multiply by 12 and get 36 eggs. And so because I multiplied by 12 here, I'll multiply by 12 here and get 24 tablespoons of water. It's certainly a double number line. It doesn't tap into the full power of the double number line. The double number line is really powerful when you're looking for oddball things in the middle, like if we had 34 eggs, how much water would we need? Then we'd really be tapping into the power of the double number line. But this is certainly an appropriate use of the double number line. And it also connects very well to how you could do a table. The ratio of 2 to 3, we've got the water, we've got the eggs, and I could scale up and scale up. So I would have 36 and figure out that I multiplied by 12, and multiply by 12 here and get 24. Of the 3 tools, the diagram, the one that really to me resonates, is the tape diagram. Probably because we've spent so much time using them that it really is a solid representation for me. Probably my second favorite is the table with the water and the eggs, and really seeing the scaling that's happening. It is fair to say that the table is probably not as much of a diagram as the tape diagram or the double number line or the graph. If we were to talk about which ones are truer diagrams, the double number line, the tape diagram, and the graph would be much more in a diagram category than the equation and the table of equivalent ratios. All right, so advantages and disadvantages of using each of the representations of equivalent ratios. So tables are very nice. They allow us to see multiple representations and look for patterns. So the water and the eggs, the water and the eggs. So we can start to look for patterns going from the water to the eggs, from the eggs to the water. We can see patterns going down the table. We can see patterns going up the table. So the table is really powerful for being able to see relationships between different values within the equivalent ratio set. The tape diagram, let's see, next is the double number line. The double number line helps us see the count by relationship. Number lines are really good for seeing that, 2, 4, 6, and we can see these numbers are locked together as they're counting up. And it does become somewhat easy to do some scaling. So if I want to multiply both of them by 5, I can have a ratio of 10 to 15. And then if I'm looking for something in between, this is where double number lines become really powerful. What if I've got 9 tablespoons of water? And then I can do some work here. So 6, 7, 8, 9, and I can see that this distance here, 9 to 15, which has a total of 6, has been divided into 4 pieces. So each piece, 6 divided by 4, so each piece is 1.5. So 9 plus 1.5 is 10.5, plus 1.5 is 12, plus 1.5 is 13.5. And I can find that I would need 13.5 eggs if I had 9 tablespoons of water. So the double number line really has some power when it comes to working with numbers in between. Equations, gosh, equations are so nice because they just give you something, you substitute a number in and you perform the operation. Water and eggs, 2 to 3. The water is 2/3 of the eggs. The eggs are 3/2 of the water, and I'm using the value of the ratios here. Water to eggs is 2/3. Eggs to water is 3/2. So now I can just choose my number of eggs, substitute it in, multiply. Well, sorry, I guess this would be this equation. I would pick my tablespoons of water and I would substitute that in to find out the number of eggs. On this equation, I can put in the number of eggs, multiply, and find out the amount of water. And then graphs we've looked at a couple of times in this lesson. Graphs can help you see visually the relationship between the numbers. And we can extend the graph to make predictions about what would happen if the graph continues. We can also look at things in between on the graph. All right, so there are lots of ways to represent the same collection of equivalent ratios, and it says several ways. These include ratio tables, tape diagrams, double number lines, equations, and graphs on coordinate planes. Hopefully, as we have used these, you are feeling more and more comfortable with what equivalent ratios are and how you can use these to illustrate that ratios are equivalent. All right, so hopefully you are feeling increased comfort with taking ratios and writing them as ordered pairs. Hopefully you are feeling more comfortable putting the ordered pairs on the coordinate plane. Hopefully you can take a ratio table and turn them into ordered pairs. Hopefully you can see that when we do the ordered pairs, we're starting at the origin. And hopefully you are seeing this is the equations that we are writing, and that value k is that constant value that doesn't change. All right, learning targets. Make comparisons. Hopefully after 15 lessons, you're feeling pretty good about writing ratios using correct language and symbols. Hopefully you're feeling comfortable reading different given situations and coming up with the ratio. We continue to find that value of the ratio, and hopefully you are feeling pretty comfortable with equivalent ratios. So I very much enjoy lesson 15 because it feels like we've been doing a lot of different things, and then in lesson 15 we get to put it all together and go for it. So hopefully you've completed lesson 15. Make sure you complete the problem set. If you've got questions, make sure you talk to your teacher.